Okay, we had this graph. To scale the graph from -4 to 12, x from -4 to 12, y from 3 to 9, we draw a rectangle that pretty much encompasses the graph, right? And not too much bigger because, especially in the x, that could cause problems. But okay, here, and if it does, you can always redo it. You'll know if it causes problems. Okay, so I did this. So x goes from -4 to 12. Well, there's -4, there's 12, and that's a direction for x, right? And for y, from 3 to 9, well, there's 3, there's 9, there's a direction for y, right? Now, we want to get the average rate of change of y with respect to x in the x interval from 2 to 6. Okay? Well, where do you think 2 is?
Well, I found the midpoint first.
Think about there.
It's like,
That looks like where you're pointing.
let me go a little bit.
Well, we could say, well, from here to here is how far?
Wait, from where to where?
Huh?
16.
16, right?
Yeah.
From -4 up to 12 is 16. We counted our fingers. We got enough fingers. Guess we don't. And from -4 to 2 is how far? 6, right?
Yeah.
So from -4 to 2 is 6, and from -4 to 12 is 16. So is 2 going to be more or less than halfway?
Less. Be less than halfway, right?
Well, 6 out of 16 is 6/16, or 3/8, right?
Yeah, it's less than halfway.
So it should be about 3/8 of the way. Well, and actually 3/8 is pretty easy to get. We divide this in half, right? And then we divide these in half, so now we got 1/4, 2/4, and 3/4, right? And now we divide these in half. They can't always do this. Numbers might be odd. You might have to do something different. Okay? And now we got 1/8, 2/8, 3/8, so I guess -2 ought to be about, +2, I'm sorry, ought to be about here. Okay? Now, you could
Label that.
divide the thing in half, see what number goes in the middle, right?
That's what I did.
Divide that in half, see what number goes there. If it's a fraction, make it a little to the left or a little to the right. You do something sensible. I don't expect high-level precision on a problem like this. I want to see something reasonable. If you put 2 here and 6 here, I'll probably still accept your work if it's correct given that. But I'm going to say, yeah, that's a pretty bad estimate for 2 and 6, right? Okay? So any reasonable estimate, you don't have to get into deep analysis, but we got 2 and 6, right? Okay? So this means, okay, if this is your function, it means you find the point here, and you find the point here, right? Okay? So let's see. Okay, we got this point, then we got this point. Then you draw the fundamental triangle. Okay? You go horizontally, you go vertically, and you got a pretty skinny triangle here. And the hypotenuse doesn't look like I drew it all that straight, but you know what it means. Okay? Now, why would you draw the fundamental triangle? Because I asked you for an average rate of change, and that's the slope of the fundamental triangle. Right? Doesn't look like it has a very big slope, but of course that depends on these scales. So the run is obviously 4, isn't it?
Yes.
Because that's, run is 6 minus 4, or 6 minus 2, which is 4. Okay, what about the rise? Well, okay, I've got 9 here and 3 here. Halfway between that is 6, so 6 would go here. And now I've got 3 from here to here, so I kind of subdivide that to see how big 1 is, right? So I kind of mark this off to get a scale for how big 1 is, right? then if this is 1, how big is this?
Maybe a half.
It looks like maybe a half, maybe 4/10, probably bigger than 3/10, right? So, without measuring it, my eyeball doesn't really tell me, but if I do this, and I do this and this, it looks like it just about fits 1 unit, doesn't it? So this is reasonable to say that this is about a half. Now you could project this point all the way over here and project this point all the way over here, and right here's your rise again, right? And you could even estimate, okay, on this scale, that looks like 6.4 and 6.9, okay? Or maybe it's 6.4 and 6.8, or 6.5 and 6.9. Any reasonable estimate is okay. If you tell me that this is 2, I'm going to say, yeah, somebody got a problem here. Let's see if we can fix it, right? Okay? But you're not going to do that. Okay, so we see that the rise is about approximately -1/2, right? And the run is 4, so the slope, I don't have to write the word slope if I know what that box means and where to put it, right? So the slope is going to be -1/2 divided by 4, right? Which is -1/8, right? Okay. Not a difficult process, but I wanted to see if you could see where the fundamental triangle is and everything. And if you didn't, you do now. Okay? So there are problems of that nature on the homework, which is why I thought maybe we'd better look at this one.